All right, now we're going to talk about two different theorems. The first one we're going to talk about is Rolle's theorem, and then the second one, which is sort of similar to it, is going to be the mean value theorem. So first we'll do Rolle's theorem. So how's that look in focus? There we go. All right, so for Rolle's theorem, we're going to have two different criteria that we're going to have met. The first one is that the function has to be continuous. Continuous, there we go, on the closed interval AB. And then it has to be differentiable on the open interval AB. All right, and you'll see that this kind of will make sense as we start looking through the theorem. Now, so if you have those two things, those two conditions, if f of a, so you have 2 points, so if f of a equals f of b, then there exists some point c such that f prime of c is 0. All right, so let's kind of illustrate this a little bit. So we got, here we go. Okay, so let's say we have some function. Well, let's draw out our points first. So let's say that this is a, and that's b. Then right here we're going to have both f of a and f of b, because that's the condition. F of a has to equal f of b. That's where we start. So if this is the case, then there's going to exist some point c that lies between a and b, where the derivative of that equals 0, or the rate of change equals 0. So let's just say, I mean, even if it draws a straight line, right, then all the derivatives are going to be 0. But let's say, just for this instance, maybe it'll just go up and then come back down. And if that's the case, there's going to be some point in here, c, where this derivative is going to equal 0. Right? And it's going to be the same thing, the same thing if it went down. Pretty much if there's a function that is between a and b, then and it's differentiable and continuous, then you know that there's going to be some point between those two, if they're equal, where that derivative equals 0. And you can see why it's important that it has to be differentiable, mainly just because we're talking about derivatives. So let's say you have your a and your b right here, but then it kind of comes up like this, whoop, and then comes back down. Well, right here you're going to have no derivative. F prime of c, it's not going to exist. So that's kind of why you need it to be, well, continuous and then differentiable, because really you have to be able to take that derivative. So okay, so that's Rolle's theorem. Then let's kind of use that and let's expand it a little bit to the mean value theorem. All right, we'll abbreviate it MVT. There we go. So we have the same two conditions. It's continuous on the closed interval AB, and it's differentiable on the open interval AB. So we still have those two, and if that's the case, then there exists some point C, or there exists, I guess, a number C such that f prime of C equals f of b minus f of a over b minus a. Okay, so let's Let me scroll down a little here. So let's illustrate this just really quickly. So what it's saying and what's the difference between Rolle's theorem and this theorem is this is saying that they don't necessarily have to be equal. Let's say this is A and this is B. So this is f of A and this is f of B. So they're not equal at this point. And then we'll just say it's connected at some point, maybe like a line like that. And so if you took the slope, which is all that this is, you're taking the slope of these two things, right, and you connected them with a line, there's going to be some point C, I don't know, we'll just say it's right there, right, so that's going to be our C. There's going to be some point where the instantaneous rate of change, or f prime of C, is going to be the same slope as this average rate of change from A to B. So that's kind of the way that most folks think about it, like if you want to put it in terms of velocity, because that's kind of an easy way that we can kind of compare or look at rates of change. So the instantaneous velocity between points A and B, or the average velocity between points A and B, is at some point along this curve is going to be the same as the instantaneous velocity anywhere along that. So let's write that down. So you could say the mean value theorem guarantees the instantaneous rate of change and average rate of change will be equal at some point. Instantaneous rate average rate at some point. So somewhere, at some point, that point we know they call it C. So that's kind of what the mean value theorem is. Let's take a look at a classic example of the mean value theorem. Let me see if I can't put it down here on the bottom of this page, because it's not a very long example. Well, let's say you're going along and you've got two cop cars, right? And this is an example you see a lot of times. So you got two cop cars. There's one, and there's two, and let's say these cop cars are 5 miles apart. All right. So let's say, like everyone does, speed limit's 55. So when you pass this first cop, you're going 55. When you pass the second cop, you're going 50 miles an hour. And so you think, oh, wow, well, I'm good, because I'm not speeding when I pass both cops. But all of a sudden, you see the second cop car, flash his lights and pull out behind you, and then he's running you a ticket, and you say, oh, well, officer, I don't understand. I was going 55 earlier, and then I was going 50 here. So, well, let's say the time that it takes to get from here to there is 4 minutes. Well, the police officer is, pretty astute. He took his calculus class, and he said, well, the average speed, let's say, how long would the average speed to go 5 miles in 4 minutes? Well, that's 5 miles, 4 minutes. All right, let's convert that, because miles to minutes, who knows that? So let's go, we got 60 minutes in 1 hour. So minutes cancel out. So that'll give me miles per hour. So take out my calculator. And I've got 5 divided by 4 times 60. 75. So, he said, well, your average speed from here to here was 75 miles per hour. And so, the police officer says, because of the mean value theorem, because your average speed between this was 75, the mean value theorem guarantees that your instantaneous rate of change, or your instantaneous speed at some point between here and here, was 75. It's a guarantee. And so, because of that, he writes you a ticket, and then off you go. So hopefully that's a good way to illustrate the mean value theorem. Both of these are ones you'll see again in proofs. And if you want to look at the proofs are actually fairly interesting. But that's the basis or the basics of these two theorems.